Most individuals engage in information work that consists of goals, timeline, and resources. Simultaneously, they are working on not just one project but several of them at the same time. We refer to these different projects as work contexts. How do individuals manage these multiple work contexts? Through cues. Cues are used to aid in reminding and also in finding. Together, these support the transition into and out of work context. Cues exist wherever we conduct our work, be they physically or digitally represented. These exist either as explicit cues, physically, such as notepads, sticky notes, or calendars, or digital cues such as email, tabs, or bookmarks. Implicit cues can include physical objects such as the piles on one's desk, where the piles refer to ad hoc groupings of spatially collated items that suggest relationships among items and their collective state of work, or digital items, where this can be seen in desktops through the multitude of windows and tabs that accumulates in one state of work. We are interested in the following. How can the spatial locations of work context artifact piles be linked to digital proxies, whether they may be active, inactive, or archived? Our project is built off of prior software and modified for the specific use for this project. The first element is WCM. WCM stands for Work Context Manager. It is a Mac OS application that enables users to, first, create explicit representations of their work context, create links with content across one's machine, this done through, first, a unique Safari Internet Browser window, 2, a unique Finder file browser window, and 3, associated documents, files, and applications that are dropped onto the application itself and linked afterwards. When the user leaves a given context, these resources are returned each time the context is invoked. State is preserved in the Finder and Safari windows.
A key challenge in the project was how to track a variety of objects such as books, papers, and notes using a relatively inexpensive yet reliable solution. RFID stickers could be used to track multiple objects, each with their own unique ID, but this becomes impractical as you would need a very fine grid of RFID readers to be able to track the location of the objects. On the other hand, machine learning image recognition requires no expensive hardware setup to track new objects, but it becomes too computationally intensive to train it to identify a large variety of items on your desk consistently, and it's also unsuitable as it can severely encumber your machine during use, and we need this tracking to be running constantly. The solution we created uses image processing and filtering techniques via computer vision. We place small colored stickered dots on each item to be tracked and center a camera above the user's workspace. We then perform 2 filters on the live video stream from the camera. The first filters out all pixels except a specific color range. Once the filter is applied and a black and white mask is produced, the circle hue transform is applied. This transform essentially looks for multiple points that lie in a relatively circular pattern within a certain threshold. Then, if pixels are detected within the specific color range, such as dark red to light red, and a circle is found in the color mask within a size close to that of the sticker, we found a colored sticker. For proof of concept, we calibrated the image processing to detect 4 distinct colors: blue, green, red, and yellow. As you can see, when each color dot enters the frame, the image processing creates a mask for that color, looks for circles, and finds the sticker. Now, in order to track the position of each object relative to the user, the camera's field of view and corresponding user's workspace are divided into quadrants. If the documents are in quadrant 1 or 2, they are close to the user, and if they are in quadrant 3 or 4, they are far from the user. As you can see, multiple objects in different locations and with different colored dots are correctly identified and tracked as they move around in the user's workspace and are mapped to a specific quadrant. While this proof of concept is fully functional, there are several features that could be added to improve the system's capabilities. First, due to the relatively sensitive circle detection of the hue transform, the color ranges have to be calibrated fairly precisely. Having an auto-calibration phase as the code starts would speed up the setup time for a new workspace. Second, our implementation is currently only tracking one attribute via one sticker per object. Since we can track any number of dots, tracking could be added to find localized groups of dots to link more than one attribute to each object. Third, since we can track the location of objects relative to each other, additional location-based relationships between separate objects could be derived for deeper contextual analysis. Thanks for watching, and we hope you enjoyed our project.